Graph. Graph is a pictorial representation of the variation of two physical quantities with respect to each other. Common types of graphs are bar graph, line graph, pie chart, etc. To describe the linear motion of a body, we use line graph. In this chapter, there are two types of graph we want to study: dt graph and vt graph. Distance or displacement time graph, that is dt graph. Jai Hind children, today we are going to study about graphical representation of motion. In linear motion, there are two types of graphical representation, that is distance time graph and velocity or speed time graph. Velocity or speed time graph. Okay, what are they? Distance or displacement time graph or velocity or speed time graph. First of all, you have to understand one thing, that is, in the case of a graphical representation, distance and displacement is taken as same. Okay, and also velocity or speed, velocity and speed is taken the same meaning. In the case of graph, distance, displacement is we will take the same meaning, and also velocity or displacement also we are taking the same meaning. Okay, so here because of that I had written here distance or displacement time graph. We are all know distance or displacement is denoted by S, isn't it? S. But here we had taken dt graph. Distance or displacement dt, time is t, dt graph. Or you can take st graph, dt graph or st graph. Here I am taking dt graph. We are going to study dt graph, that means distance or displacement time graph. Okay. Here in distance and time, we are all know distance with respect to time, that means what? Distance and time is there. What we can find out from this? We will get speed. What will get? Speed. Okay, so this distance and time graph gives speed of an object. Distance and time gives speed of an object. Okay, then from this, here d is represented on y-axis. This is a graph. Now graph consists of y-axis and x-axis. Here d is represented on y-axis and time is represented on x-axis. Okay, time is represented on x-axis and d is represented on y-axis. Okay, it's very important. We will study the dt graph of a body under the following conditions. The conditions are dt graph. We are going to study these following conditions. We are going to draw the dt graph when a body at rest. We don't know which type of graph we will get. Okay. Then when a body is moving with a uniform velocity. Then when the body is moving with a non-uniform velocity, non-uniform speed. Uniform speed, non-uniform speed. That time which kind of graph we will get, that we are going to discuss. Condition 1, when a body at rest. At rest, which type of graph we will get? We'll give one example, that is, you just take distance on y-axis, no? Distance and time. Here, distance 10 meter. Our object is already in 10 meter distance. And in 0 second. 1 second it is also the same distance. Second it is in same distance, and third second it is in maintain the same position. Is it is moving? No, it is already it is in 10 meter and it maintain that particular position. It is not moving. That is when a body at rest. Okay, then we are going to draw the graph. That is, what is that? Here distance is taken, y-axis is taken as distance and x-axis is taken as time. So in 0 seconds, 0, 1, 2, 3, okay, up to 3 seconds, no? Yes, in 0 second the body is in 10 meter, and 1 second the body is same the 10 meter. Second also it is in 10 meter. Third second also it is in 10 meter. So we will get the graph is straight line. It is parallel to time axis. Okay, which kind of graph we will get in the case of body at rest? In DT graph, we will get the graph a straight line is parallel to time axis. Graph. How can you find out the speed of an object from A to B? Speed of an object from A to B. Speed is equal to distance by time. Okay. Here, what is the distance? 10 A to B, what is the distance? 10 meter minus 10 meter. Divided by time, 2 minus 1. What will get 2 minus? Up to here, no? Yes. 2 minus 1. So 0 by 1, what will get? 0 meter per second. From this also we got what? 0 speed. That means the object is at a rest. This also, from this that graph also we got the object is at rest. Okay, so like this you have to find speed from the graph. So from the examples, we had done the example, no? From the example we can understand when the body at rest, which kind of graph we will get. The graph is, this is the answer. Through an example I explained on which type of graph you will get. When a body at rest, D on y-axis, T on x-axis. That time, which type of graph we will get? It is straight line parallel to time axis. The graph is straight line parallel to time axis. This is the answer. So when you are writing note, you just write when a body at rest. First condition, which type of graph you will get? It is straight line parallel to time axis. Then write down straight line parallel to time axis. If you want, then you just do the example. Example I explained, no, that 10 meter and 0 second, 10 meter in 1 second. That if you want, that also for understanding, that also include in your note. Okay. Condition 2, when a body in uniform speed. Okay, next condition is when a body is moving with the uniform speed. Okay, when a body is moving with uniform speed. First I will explain the example. With the help of the example, we will conclude which kind of graph we will get. Okay, when a body is moving with a uniform speed. Example, I am going to explain example. That is the data table. The table is here D and T. Time. Here time in 5 second, 10 second, equal intervals of time, no? 15, 20, 25. And the case of distance, 20, 40, 60, 80, 100. Okay, I am going to draw the graph. That is 5 second, 0, 5, 10, 15, 20, 25. This is time axis. And distance, what? 20, 40, 60, 80, 100. Okay. Here, you all know how to draw the graph. Draw a graph. In 5 seconds, 20 meter distance it covers. And next 10 seconds, 40 meter distance. Yes. Then 15 seconds, 60 meters. 20 seconds, 80 meters. 25 seconds, 100 meter it covers. So we will get the graph is straight line but not parallel to time axis. Graph is straight line but not parallel to graph. Here also we will get the graph is straight line but not parallel to time axis. Okay, not parallel to time axis. This graph is known as slope. What is that? Slope. We will get a slope graph. Okay, slope. Then when we will get the graph like this, we can find out, we can apply another equation for finding speed. Slope is equal to, this slope is, this is distance, this is time. So the slope is the speed, isn't it? Yes. In the first case, we got the graph like this. That time, this is one y-axis on distance and x-axis on time. This graph gives the speed. Okay, this is the graph. Inside of that x-axis and y-axis, what we'll get, that is the graph. Okay, here the what is the graph here? Slope. This graph gives this speed of an object. So slope is the speed of an object. Slope. How can you find out the slope? That means how can you find out the speed from this graph? That is measure on y-axis divided by measure on x-axis. Measure on y-axis divided by measure on x-axis. This is very important. How can you find out the slope of the graph? Here what is the slope? Speed is the slope. This is speed, no? Here distance here, time here. So this is speed. Then slope means here speed. How can you find out the slope of a graph? If we are getting a graph like this, we can find out with the help of this formula, that is measure on y-axis by measure on x-axis. How can you find out the speed here? Speed is equal to slope of the graph. How can you find out slope? Slope is equal to measure on y-axis by x-axis. Okay. Here I am taking 2 points A, B. In this, we can draw a parallel line on time axis and also parallel line on distance axis. We are taking what slope of AB. Okay. Then slope AB is equal to y-axis D1, D2. Here what? T1, T2. So we can take D1, D2. D2 minus D1 divided by, this is y-axis, no? D2 minus D1 divided by here x-axis. T2 minus T1. What will get? What will get? D2 means 60 minus D1 is 40 divided by T2 minus T1, 15 minus 10. What will get? 60 minus 40, 20 divided by 15 minus 10, 5. So 20 by 10, answer 4 meter per second. What is the answer? What is the answer of a speed? Yes, 4 meter per second. Conclusion of condition 2, when a body moving with uniform speed. And this condition, which type of graph we will get? Yes, already we discussed the graph is straight line. It is not parallel to time axis. Graph, which kind of graph we will get? It is straight line but not parallel to time axis. It is not parallel to time axis. No, this graph is here. What will this graph is always known as slope. What is the slope graph? We will get. The slope means here speed. How can you find out the slope? Yes, slope is equal to measure on y-axis by measure on x-axis. Have to study this only. If you want to write the example, include that example also. Okay. Condition 3, when a body is moving with non-uniform speed. When a body is moving with a non-uniform speed, here we will get graph. No need to write the examples. Non-uniform motion, non-uniform speed or non-uniform acceleration. In this case, we will get the graph is like this. This graph or this graph like this. Okay, it is not in a straight line graph. In this case, we will get the graph is not in straight line. It is not in straight line, no? Yes, not in straight line. Condition. These are the conditions of graphical representation of motion in the case of DT graph. Conclusion of DT graph. Object is at rest. That time, which kind of graph we will get? The graph is straight line. It is parallel to time axis. Second case, uniform speed. Uniform speed. That time we got the graph is what? Slope graph. It is straight line. It is not parallel to time axis. Non-uniform speed. Non-uniform speed. That time, which kind of graph we got? Curved graph or not in a straight line graph. Okay, curved graph or not in a straight line graph. And this condition, these are the graph. Okay, here speed is 0. This is speed. This is also speed is in slope. This is not a slope, not a straight line graph. In which this condition, how can you find out distance? Speed. That is, speed is equal to distance by time. Okay, in this condition, how can you find out the speed? You'll find out with the help of slope, that is y-axis by x-axis. Then in this condition, in your syllabus, there is you don't want to find out the non-uniform speed. If you want to find out the speed, you can choose any 2 points. Okay, then from that point only you can find out the non-uniform speed, like this. Slope is equal to y-axis by x-axis, like that. Okay, then these are the 3 conditions for finding the speed and DT graph. The conditions: object at rest, object in uniform speed, object in non-uniform speed. These are the things only you want to study for a graphical representation of motion in DT graph. I explained with example. If you want to write the example in your note, you can write. Otherwise, you just understand how to find the speed from particular conditions. Okay. Thank you. Stay home, stay safe.